Right. So this is the equation for drift velocity. Let's have a look how I derived it. If we've got a wire of length L with all these electrons in it, we can say capital N represents the total number of electrons in that bit of wire. And clearly the wire continues later on, and it's all part of a circuit. It has a cross-sectional area A, and the V is how fast the electrons are moving. So the length of the wire is going to be equal to the speed or the velocity the electrons are moving multiplied by the time we're thinking about that it takes them to move from the beginning of L to the end. That would be how many electrons would pass through this length of the wire. So, and the next thing we want to look at is the volume of the wire is going to be equal to the area multiplied by L, and subbing in that definition of that equation for length, we can bring that down to here, and we can say the volume of the wire is equal to A times V times T, little v that is, multiplied by T. Meanwhile, over here, we can say we know the current of the current can be calculated by the charge transferred through that wire, part of the wire divided by the time. And the total charge is going to be equal to the total number of electrons multiplied by the charge of each electron. Subbing that into there, we can say that current is equal to the total number of electrons multiplied by the electron charge divided by time. We then look at how can we calculate the total number of electrons in terms of density of electrons. If the density of electrons is the number of electrons per meter cubed, then we'd be able to calculate the total number of electrons by multiplying the density of the electrons by the volume. And we derived this part of the equation for volume earlier on. So we can put that together with this one, and we can say the total number of electrons would be equal to the density of the electrons multiplied by the cross-sectional area multiplied by the drift velocity multiplied by time. And now we've got an equation for the total number of electrons. We had earlier on an equation for current with the total number of electrons in it, and we put these two together, and we have current is equal to the density of electrons multiplied by the cross-sectional area multiplied by the drift velocity multiplied by time multiplied by the electron charge divided by time. This time came from there, and that time came from here. But they're the same time, so they're going to cancel out. One's at the top, one's at the bottom. And we end up with the equation for drift velocity. I is equal to NAVE, or NAVE, you can think about it like that, a way of remembering it. The density of electrons, cross-sectional area of the wire, drift velocity, and charge of the electron. Okay?